that a sample example we will take, because the above examples are very small, so we'll take some sample example which is a bit bigger. So nums1 and nums2, we want median is nothing but the mid element. So if we have even number of elements, as you see, if we have 4 elements here, so for sure the median will be the average of the mid 2 elements, right? The average of the mid 2 elements, and the mid 2 elements, as you will see, firstly I just got these elements in one array. I just sorted the entire array down. I got this ARR array after sorting. This means I just combined nums1 plus nums2. I got the array added, and then I sorted that array. I got the new array. Now I can just say that, okay, I have nums1 plus nums2, which is the sorted ARR array, and then in the mid I'll go and find what are the mid elements. That will be, and I'll take the average of them. If it is even, if it's just odd, I'll take the mid element. If it's even, I'll take the average of the elements, and I'll get my median. Okay, so you can see that I'll just simply merge the arrays. I simply merge these two arrays. I took find the median. I just took the average, which is 3 plus 5 by 2. Answer is 4. So median is 4 for this specific array. So you will see, as I combine two array, which is O of n plus m operation, and then to sort a O of n plus m array size, it will take a m plus n log m plus n time, and the space will be O of m plus n. But bhaiya, you made a new array. Oh yeah, you made a new array. For that, the space required will be O of n plus n. Although you can combine in the existing array itself, but yeah, in total the space required will be n plus n. For sure, this is not even using our concept of sorting, as in the arrays are sorted. So let's try to see that, okay, what if we try to use the arrays are sorted itself? So ultimately, if we look back, we have to figure out, okay, if we just say that bhaiya, we have an array of 8 elements, right? So I for sure know that I will be requiring my 4th and the 5th element, which means that if I just bifurcate that array into half, which is 4 elements on the left, 4 on the right. So you will see that I am just needing the 2 elements. So I just need this portion only at max. This portion. If I go from any end, either left or right, I just need one portion. So okay, one thing I got to know that, okay, it is sorted. This array is sorted. Nums1 and nums2 are sorted. I just have to reach to this point. Now bhaiya, what is the point of reaching this point? So what I'll do is, I know that my arrays are sorted, right? So I can go and use 2 pointers, one on my nums1, one on my nums2, and then we'll keep on incrementing. But bhaiya, what will happen? I know that I will go up till this point only. But what I will do meanwhile, I will make sure that I am saying, okay, this is my maximum element 1, this is my maximum element 2. So in the last, when I would be reaching at this point, I will have my maximum element 1, which is the current maximum element up till this point, and the maximum element 2, which is the current maximum element, like next maximum element, which is the second smallest or second maximum element, I will have as m2. With this, I would be knowing at this point who is maximum and second maximum, and with this I can take the average of these two and get the answer. So it is only possible because these two were sorted, and I can just in 2-pointer way move on both the arrays, which is nums1 and nums2. So I'll do the same thing. Now bhaiya, what is this point? This point, if you just closely look at, it will be nothing but n plus m by 2. N plus m by 2, because index from 0 to n plus m by 2. So okay, that is great. So as you saw that if I am standing here, so I'll just compare the values. So I'll just say, okay, if both are comparable, at least I can compare both of them. So if I can compare both of them, which means both are in bound of my nums1 and nums2, bhaiya, what if it is outside? Oh, if it is outside, then we will see the case. But right now, I can compare both ing. ing are valid. So it says ing both are valid. Now, if both are valid, I'll just say, okay, whosoever is small. Now, if nums of I is less than my nums of j, if nums of I is more than my nums of j, else will come nums of I is less than my nums of j. So whosoever is less, as you will see, nums of 1 of I, it is less than nums of 1 of I is less than my num1 of I is less than my num2 of j. So I simply, as you will see, I am simply assigning my new upcoming element to my m1. And bhaiya, but You were saying that you'll assign the maximum element to m1 and then next minimum element to m2. Yeah, true. But you will see that, okay, I'm only assigning in every comparison, I'll only assign m1. So whosoever is smallest right now, okay, 1 is smallest, assign it to m1. Here you will see m2 is smallest, like m2 is smaller, right? So assign to m2. Sorry, assign to m1. I'll assign only to m1. Only to m1 I'm assigning. But bhaiya, what about m2? M2, when you will assign that? So basically I'll just say in the end, as in the end, which means at every iteration I'll be saying, okay, m2 assigned back to m1, m1 assigned back to m2, m1 assigned back to m2. So basically m1 will be, okay, right now if I just compare, okay, right now m1 will be 1, then my I will go here. As soon as my I go here, so m2 will become 1. Now m1 will become minimum of them 2. Okay, great. Now it will go again further. So now as soon as I'm starting to compare the next one, I'll firstly assign my m2. Okay, now my m1 will again minimum of them, which is 3. Anyone. So I can just take anyone. Let's say I move this or this, anyone. It doesn't matter. Now I'll say before comparing will assign my m2 to m1. Now I'll compare. Okay, it is again m1. So again I will have to move, which is for sure I'll move my j, because this is what I compared. So okay, again it is about to compare, assign this to m2, assign again minimum m1. So you saw with this my m2 is the second smallest and m1 is the small, like m1 is the maximum and m2 is the second maximum, and with this I can get these m1 and m2. So again bhaiya, what if my I is finished, which means what if my j is finished, then my I is still remaining, right? If my j is finished and I is still remaining, this is the case when my j is finished. Bhaiya, but there is no condition for j. Yeah, I'll put this condition first, and then if this is not satisfied, I'll put this condition. Which means if I is less than j, then you just say, okay, m1 is your num, so fine. But bhaiya, what if my I is not there? Okay, then if j is less than n, then try for this. So this is how we can split the functionality of a code, and the same way I'll show in the code. Although I have explained it with writing down, but yeah, the same way the code itself look like. I will have a I, j, m1 and m2. Again, you know m1 and m2, m1 is the maximum, m2 is the second maximum. I will be going in from count equals to 0 to count is less than equal to n plus m by 2. It is not less than, it is less than equal to, because I have to go up till this point. Up till this point I have to go. Okay, great. Then for sure, as you remembered that as soon as I do the next iteration, I have to assign my m2 to a m1, right? I have to assign my m2 to a m1. So as I can now modify my m1. I can now modify my m1 here itself. So what I'll do, I'll just say, okay, if both are actually valid, which means if I is not equal to n and j is also not equal to m, then I can just simply say that assign depending upon whosoever. Okay, if nums1 of I, if nums2 of j is smaller, then assign m1. If nums1 of I is smaller, then assign to m1. Now when this is done, else if condition, okay bhaiya, what if my j has reached the end? No worries, if I is still there, then okay, now assign my m1 to nums1 of I, else assign my m1 to nums2 of j. Now with this I have assigned my nums1 and nums2. That is done. Now simply just you have to find what? Median. So what I'll do is I'll just check if the actual median, if it's just an odd number, which means I have just one element, it's just an odd number, so simply assign your m1. If it's an even number, then you will assign the average of m1 and m2, and that's what you will do if it is odd, if it is even. And that's how you can simply solve it in O of n plus m time in space n O of 1. And that's how most companies are always like, okay, that's great for you. But if you remember, the problem says one thing. The problem openly says that, can you please solve it in log of n plus n time? So we are forced to optimize it much more further. Now, if it is something is sorted and we kind of start thinking of binary search. I'm not saying it is important that we should apply, but we will indirectly think, okay, binary search can be applied. But the major fact is on what thing you will apply binary search. Okay, you have to apply binary search. That's true. I'm not denying that. So binary search can be applied on a number. Usually what you do, okay, bhaiya, my range is from 0 to 199. So I apply on that range, which means I'm applying on my range itself, which means the number. Let's say if my nums array has values 1, 2, 3, 4, 5, 6, 7, 8. So I'm applying on those numbers. Okay, what if my value is 8? What if my value is 10? I'm trying for that number value itself. Other option is what do you usually do? You apply the binary search on the length itself, which means okay, bhaiya, my array is of length 10. I'll try for smaller length array. That is the other way you can apply binary search. Now let's see, can we apply binary search on the number? Now number is nothing but we'll just try to find mid 1 and mid 2. Now how you will find? Okay, apply binary search on a number. My ultimate aim is to find a median. Median is itself some number which is in between. It has no relevance with the value of a number. Let's say if you have an array 1, 2, 100 and 101 and 102. So 100 is the median. So you saw the number difference can be a lot. I'm just concerned about the length. So for sure, I will have no criteria. Okay, how much number can be bigger? How much can be smaller? It's just at the location, the length from where, okay, either left or right, the length of that number will matter. So I know that, okay, my length will actually matter, which means the length of, let's say if I combine this entire array. So the length of this part. Now, bhaiya, how this length is obtained? For sure, this length is obtained half, like a small portion from the nums1 array of left itself and small portion of the nums2 array of left itself. With this, I have combined this left portion and got this part. So I'm just only concerned about the left portion, which means I'm only concerned about the length. So that is one intuition which we have got right now. Okay, I cannot binary search on the number itself. I have to search binary search on the length. Now still we are not sure, because binary search is something which is applied on that, okay, I have a wrong, right. So basically it is saying that for these lengths, which, because now we have to make sure, okay, I have to apply binary search on the length itself, but now I have to again make sure that, okay, binary search is something which we apply on, okay, it should for these lengths, which means my length will be actually increasing or decreasing. So I'm just indirectly saying, okay, for smaller lengths, it should not be valid. For bigger length, it should be valid. So either it should look something like this, or I should be able to anyhow figure out the conditions that if I'm standing on some length, let's say my mid is my length. So I have to increase the length. I have to decrease the length. I have to figure out with the help of my array itself. So let's see how we can do it. Now my ultimate aim has now figured that, okay, I have some left portion. Now this left portion is the length. This left will be for sure fixed. Bhaiya, how it is fixed? Because your entire length is of size 8. So for sure your left part, which means if your length is 8, forget for now that if you have odd elements. Right now just imagine that you have even number of elements. So if you have even number of elements, for sure the left portion will have for sure 4 elements, for sure. So this is fixed. But the thing which is variable for you is that how much of it has come from the nums1, how much of it has come from the nums2. That is variable for you. So that is what we will try to apply binary search on. Okay, that we will do. But bhaiya, what you said, okay, left, which means you will try to figure out this portion. So you will say, okay, it is n1, it is n2. So n1 plus n2 by 2. So basically you are saying that left is 4. So did you find this 4 by saying 4 plus 4, which means n1 plus n2 by 2? This is how you found your 4. I'll say yes, but partially, because here we only considered length as even. What if the length would have been odd? So if the length would have been odd, so if you would have done n1, let's say here it would have been 5 elements. So still you would have got a 4. But you will see that, okay, you might have a 10 also. So in the right part, you will actually have more elements. But you remember, your median will actually be 5. Remember, because here are 4, here are 4. So basically, in case of odd number of elements, I should consider my left portion as this portion, which means, okay, the elements which are actually equal on the same side, and also that element itself. So in case of even odd number of elements, I should say that this should be my left portion size. And how this is possible? But just by simply saying that I will, instead of taking n1 plus n2 by 2, I'll take n1 plus n2 plus 1 by 2. With this, I'll considering left, okay, like if I just say n1 plus n2 by 2, I will be considering only half elements. Let's say 5 by 2 would have been a 2, which is saying, okay, I have only 2 elements. But now I'll say, no worries, I will have plus 1 by 2, which means I'll have 3 elements. So this is the 3 elements. So with this one formula, it will handle both even and odd cases for us. So that is a bit part which might be tricky. Again, this is a problem which, if you have not solved it earlier in a 45 minutes interview, it's a very hard to come up it and code it at the same time, because its explanation is itself very tricky and long. Now coming on back, अपना मकसद हमें बोलना है, our main aim was to binary search on the length of the left part from nums1 and nums2. So you will see the pink portion is the left portion from nums1, pink portion is the left portion from nums2, red portion is the right portion from nums1, red portion is the right portion of the nums2. Now if I choose any one of them, if I just choose any one of them, let's say I choose this as 3, for sure everything else will automatically be set, which means if I choose this as 3, right, I know for sure that my length is actually a 4, half length is actually a 4. So for sure this next, if it is a 3, it should be 1 to actually sum up to a 4. And the same way, if this is 3, its entire length is 4, so for sure remaining portion is a 1, so for sure if remaining portion is 1, this is again a half length, so it should also be a 3. So I just need to do a binary search on just one length, any one of out of these 4 lengths, which is this length of the left part of nums1, right part of nums1, left part of nums2, or right part of nums2. I just have to do a binary search on just one of the lengths. That's it. So now I will choose to do a binary search on my nums1 left part. Now let's see that how we can actually do it. So we have just said, okay, we ultimately are just trying to figure out the final array left part. So for that, I'll just do a binary search, which means, as you see, mid1 is after doing a binary search on the left length of nums1, and indirectly I will always be able to find the left length of nums2, which is left minus mid. It will be the mid2, which means the left length of, I will be able to figure out the left length of num2, or basically the mid2 I will be able to figure out with actually mid1. So I just need to figure out this only. With this I can easily figure out my mid2. Now comes the interesting part. I have to start doing my binary search. Let's do that binary search itself. So as you can see, binary search, which means, okay, you will find mid, but remember, I am doing binary search on length. If I am doing length can be either 0 or the entire array itself. So my length, again, that is doing on nums1. I will do my binary search on nums1. With nums1, I will derive my mid2 for nums2. Remember that fact. Okay. Now this low equal to 0 is saying, okay, my length is 0. This high equal to n1 saying my length is n1. Remember this fact. Okay, and it is to just showcase, because I will actually derive my mid, and mid I will place at some location. So that is the reason I am just pointing, okay, 0 is actually showing you, okay, it is at this index, but indirectly you will see that, okay, I am doing a binary search on my length itself. Great. So 0 says I have 0 length in the left portion of nums1. n1 says I have n1 elements in the left portion of nums1. Now if my low and high are derived, let's go and find our mid. So simply low plus high by 2. Again, you can also say, bhaiya, why not low plus high minus I, like low plus high minus low by 2, that formula. But yes, still your low and high are very small, so you can just simply do this also. Now low and high by 2, you get your 2. Now 2 is your mid 1. Okay, mid 1. Now this says that in my left portion I have 2 elements, but I will have to handle indexes, right? I have to handle indexes. Like my array is index based, so that's the reason I just plotted my on the index itself. Mid 1 came out to be a 2, so I just plotted here itself 2. Now you remember that your left portion has only 2 elements, right? So now and again, because of this mid 1, I will always be able to figure out mid 2. So mid 2 is left minus mid 1, because mid 1 is saying, okay, in nums1 left number of elements are mid 1. So for sure in mid 2 left number of elements will be total elements in the left minus mid 1, which is 4 minus 2, which is actually 2. So again my mid 2 has been there. Now I have figured out my mid 1 and mid 2 by just mid 1. Now comes the interesting part. I know my mid 1 is here, I know my mid 2 is here, which means my left elements are 2 elements. My left elements are 2 elements in nums2, which means my right elements are these. My right elements are these. Now comes the interesting part, that if you have to plot these elements, how will you plot this? you have a 1 2, right? So let's imagine that you are only you will have these left part as sorted, right part as sorted, and you just have to combine that part. Why we bifurcated this part? We just said, okay, I will sort my left part, I will sort my right part, can I combine them? Can I combine them? So imagining if my left part is sorted, okay, it is 1 2, it is 3 4, I have sorted this left part, right? 1 2 3 4, 1 2 3 5, it is sorted. Let's say my right part, okay, 3 7 7 9, it is also sorted. As but you will see, it is nums 1, it is nums 2. So just for you to imagine, I just put it like this. Now to actually know if I combine them, which means now after combining I cannot sort them. I'm just saying, okay, this part is sorted, this part is sorted. Is it possible? Is it possible to combine them? Which means this should be less than your 3, right? That is what it case. And also bhaiya, again, okay, for now your nums 2 part is like in the end, but what if it would have been some smaller number 1 1, then you would have said, okay, it should be less than this number. So now we have imagined that we will have two conditions. Our L1 should be, what is L1? Simply, you remember your mid was pointing here. So nums 1 of mid 1 will be R1, right? Nums 1 of mid 1 minus 1 will be L1. And the same way, nums 2 of mid 2 will be R2, and nums 2 of mid 2 minus 2 will be L2. So basically, I am saying indirectly that, okay, this is my L1 element, it is my L2, it is my R1, it is my R2. Now I have got these L1, L2, R1, R2. Now when I have this L1, L2, R1, R2, I'll just say, okay, condition for after combining, for it to be sorted should be that L1 should be less than equal to my R1, and also L2 should be less than equal to my R2. Only then my array after combining will be my sorted array. So now I have said, okay, this is the condition for it to be sorted. So now I'll check, is this above thing valid, which I have made by doing a binary search on the length itself, is this valid or not? So I'll say maybe it is not, but I'll see that, okay, 5 is not less than equal to 3, 5 is more than 3, which means it is not valid. This is not valid. So what we have made right now, it is not valid. So because you remember, I was planning something like this, and for sure this thing is not valid only and only because of 5 is more than equal to 3, and it should have been less. L2 should have been less than equal to my R1. But bhaiya, why you did not check L2 is less than equal to R2? Because L2 is sorted. This thing is already sorted. This thing is already sorted. So for sure, you don't need to compare that. You just only need to compare the diagonals, because horizontal are already sorted. So this is the condition. Now bhaiya, depending upon the condition, how would we know that where we have to move, left or right? Because ultimately binary search is, okay, you have this value, where are you planning to move, left or right? That is what you have to figure out. So I will just say that I will have a low, I will have a high, I got a mid. With this above scenario, I have got something like this. Now here you remember, my L1 was less than equal to my R2. Now this was not following, right? Which means for sure that I have to shift my left to this part such that 3 should have come here. Then I would be comparing with my 9. So and again, bhaiya, why you did not move your L2? Like bhaiya, why you did not move your your value in nums 2? Because if you remember, I was saying I'm applying my operation on nums 1 itself. So if 3 is here, I can apply operation on above nums 1 array itself, because I'm just doing a binary search on nums 1. With nums 1 help, I'm applying, or basically saying for nums 2. That is what I was doing. So I can apply operation. So if this is not handling, if this is not being handled, which means if your L2 is less than equal to your, if L2 is less than equal to your R1, then okay. But if it is not, which means you have to shift your value to the left, which means your left will come here, right? Because it's a pointer, left will come here. So now your left portion will actually be increased. So I just do the same thing. If my L1 is less than equal to L2, which means, okay, L1 is less than equal to L2. Now, because if it is invalid, so for sure, if this is less than equal to L2, which means L1 is less than equal to L2, which means it's a bad condition. But I am I'm counting for invalid ones. So for sure I will compare and I will say, which means this would have been invalid. So simply move your L1 to the right. So I'll do a low as mid plus 1 and vice versa, true for high equal to mid minus 1. Again, a recap that I will be doing a binary search on the nums1. So I have to move my L1 and high, like low and high of the nums. I know that if L1 is less than R1, so for sure it is correct, which means this would have been incorrect. This L2 less than equal to R2 would have been incorrect thing. So for sure what I will do is I will have to move my low to mid plus 1, low to mid plus 1, and same vice versa will happen for if L1 is more than equal to R2, then I'll move my high as mid minus 1, and that's how I can simply solve it. So now we saw that because of our L1 is less than equal to our R2, which means for sure L2 would have been more than equal to our R1. So I will have to move my low forward such that the new left range would have become the further range. What we mean by that is our low will move mid plus 1. Mid was actually, if you remember, it was 2. Like it was pointing to a location 2, index 2. If we go up, it was a 2. So I will do a mid plus 1. So my low will become a 3. High would for sure be as it is. So my new mid would be a 3. Again, because of my new mid, I can easily find my new mid 2. Again, left minus mid 1, 4 minus 3, actually 1. So now my mid 1 is 3, saying I have 3 elements in the left pointing to index 3, and mid 2 is same one element in the left and pointing to index 1. Now mid 1 is here, mid 2 is here. Now let's see that how will our new array look like. As I said, I will have left elements 1, 2 and 3. Left elements 1, 2 and 3. Left elements just a 3. Left element just a 3. Right elements from here is 5, 7, 7, 5, 7, 7. Right elements from here is a 9. So now you will see, okay, what happened? Because of moving my low pointer in forward, number of elements here increased. Because of increasing number of elements here, number of elements in nums2 decreased. Number of elements in nums2 decreased, and because of decreasing number of elements, the value will be lesser because elements are decreased, which means elements will go leftwards. If they go leftwards, which means elements are decreased as in I have less number of elements, which means I will have smaller number of elements here, and I will have larger number of elements here. So for sure you will see that 3 is now less than equal to 9, like less than 9. And same way I also have to check L1 because it might happen because of this decrease, this might end up increasing. That's also happening. So that's the reason I'm using a binary search. So I'll just say, okay, this is less than this, that's true. This is also less than this, that's also true, which means it is a valid case. Now if it is a valid case, I would know that if L1 is less than equal to R2, L2 is less than equal to R1, which means it's a valid. Now if it's a valid, again we have to condition, we have to find mid, right? Mid will be nothing but if it's odd, which means if it is actually a odd length, so I'll just do a maximum of L1 comma L2. Else I'll just do a maximum of L1 comma L2, minimum of L1 comma L2, and then I'll just do a by 2. Now bhaiya, what you did here, okay, we understood that, okay, it is odd or even, so you will do you will just get one element and you will take the average of 2 elements. But how you wrote this formulas, so if you remembered, I said specifically that if my length is odd, 1, 2, 3, 3, 5, let's say if my length is odd, so I will be taking my left portion like this, right? When my left portion is like this, so one thing is for sure that I will be having my L1 and L2, which means if I bifurcate this array, let's say it is becoming like, okay, 1, 2, 3, and let's say 3, 5. Let's say I bifurcate this array. So for sure, my L1 will be here, L2 will be here, or maybe let's say the entire thing is here. So for sure, my, let's say here is L1 and below is L2. So my L2 is actually null, which means 0. So one thing is for sure, I am taking the maximum of what L1 or L2 would have got, because L1 and L2 are pointing to the left portion. Now left portion is nothing but this entire left portion. So L1 or L2, left portion. If it's left portion, I'll just get the maximum. What's the maximum? Will be this element, extreme left element in the left bar. So I'll get the maximum of left 1 and left 2. But bhaiya, what about this? Simple. As you remembered, if I had this array in the left, so I will have L1 here, I will have L2 here. If I have L1 here, L2 here, simply, you remembered these elements, if I have to write, oh, that's a 3 and that's a 5. So what we can do is, okay, we know that this is the left portion, this is the left portion. So I will just simply go and grab the maximum from the left portion. Okay, it will give me the maximum from the left portion, because you will see left portion is this, maximum from the left portion is this. This is the right portion, this is the minimum of the right portion. So I will go and grab the R1 and R2 and take the minimum of the right portion, and thus my answer will become maximum of L1 comma L2 and minimum of R1 comma R2. I was actually like, that's a typo in here, but yeah, that's a minimum of R1 comma R2 and just by 2. By this you will get the answer for you. Now what we have seen in this is, now we'll club the entire code. How we'll club the entire code? We will say that I have N1, I have N2. Now, if my N1 is more than my M2, then simply I can just swap it, which means I'm just saying that I will just always try to make sure that my N1 is less than N2. So that is just for my safety, so that I will have lower number of comparisons. But bhaiya, why? Because you saw that you are doing a binary search on your nums1. So if nums1, you will try to keep it small. So your binary search length, which means log portion, will also be small. So here I am just trying, okay, I am doing a binary search on the smaller length itself. That is a small optimization. Again, that's not a big optimization, but yeah, that's a small one, which interviewer might actually feel good if you do it. Now comes the interesting part. I will find my left. It is the left length, as I showed you. It is, again, I had options of N1 plus N2 by 2 also, but then I said N1 plus N2 plus 1 by 2 will handle both the cases for odd and even. So I did like that. Okay, great. Now I have my low, I have my high. Low is the length. Left nums1 left portion minimum length, it can be 0. Nums1 right portion minimum length can be N1. But I wanted to have indexing, that's the reason I will just show you as indexing also, and also show that, okay, it's actually length itself. Now I just went on a simple binary search. Now how a binary search works, you just do a while low is less than equal to high. Again, it depends. If you do a less than, then you have to modify the conditions, but I usually do a less than equal to. I do this, then I find my mid, and the condition comes here, and if it is satisfying, then it is either mid plus 1 or mid minus 1. That is a binary search standard template. Now comes on that what are the changes which we have done. We have just found out our mid one. Mid one is nums1 portion, saying, okay, mid one is nums1, like mid one, which is low plus high by 2. Same, mid 2 I can derive from mid 1, which is left minus mid 1. Okay, now I have got mid 1 and mid 2. Now I will have to find my L1, L2, R1, R2. So L1, L2 minimum, R1, R2 maximum, because I want to maximize this, I want to minimize this. That's the reason. Now these conditions, as I showed you in the beginning also, that if your mid is less than your N1, then only you can just say, okay, your R1 is actually nums1, like nums1 or mid 1. If you remembered here itself, when we have to derive what are all our values of mid 1, mid 2, nums1, nums2, we said the same thing. Where is gone? Yeah, as you remembered, R1 is nums1 of mid 1, L1 is nums1 of mid 1 minus 1. So now I'm just saying that, okay, nums1 should not, like mid 1 should not be 0, mid 1 should not be n. So it is a like standard check to actually validate that I should not get a runtime error. I should not get a runtime error. So I just did a standard check. Okay, mid 1, if it's less than L1, then only I'll assign my R1, I'll assign my R2, L1 and L2, right? Now, when this is done, again, if you might have seen, okay, like I'm looking at this phone because I'm getting some calls and I just don't want to, I forget my time. So I'm just said one thing, okay. Now I have seen that my L1, L2, R1, R2 are with me. Now, where we have to move, that will depend upon the condition which I saw. Firstly, is it even required to move? That will check, okay, if L1 is less than equal to R2, L2 is less than equal to R1, which means it's a valid condition. Now just go and return. Okay, if it's odd length, like return maximum of L1 and L2. If it's an even length, return the maximum of L1 and L2 plus minimum of R1 R2 by 2. Okay, but if it is not a valid case, then Okay, as we discussed, that if L1 is less than R2, which indirectly will mean that L2 is more than your R1, then you have to move your low to mid plus 1, and vice versa you'll do for high equal to mid minus 1. And that's how ultimately you can return your 0 if you don't return from either here or here, right? And that's how you can simply get this solved in your O of log n time or O of log m time, whatsoever is small, n or m. And space is also O of 1. And that's how, again, it's a torture question, but yeah, it's a very good question for you to be asking into, because it has many follow-ups with an amazing mindset of binary search, 2 pointers, and a basic brute force also. Cool, thanks for watching.